In today's session, we're covering a review of the comparative statistical tests, which we covered last week. I always think it's a good idea to go back over the tests to see how they all fit together and how we use them. So, first of all, our comparative statistical tests is a good level of test when it comes to evidence based practice because, unlike the correlations, we do have the ability to note causality with this level of test. So first of all, you will remember that I divide all quantitative research studies up into 5 different groups. When we're first looking at a phenomenon and we don't know what variables are involved, we might start off with a qualitative research study. A qualitative approach is one where we make observations, we record what participants tell us verbatim, we have pages of text, and from this we can look for themes that sort of bubble up, that become variables that we can go back and measure. So that's the qualitative approach. That's where we often start when we have a new phenomenon and we simply don't know what variables are involved in that phenomenon. Once we have variables, we like to measure them, and we start off with a descriptive level. The descriptive level of statistics is one where we have questions that are sort of like how much type questions about one variable. By example, I always use is if we had a question such as, what is the level of job satisfaction of staff nurses in Louisiana? In that case, there's only one variable, job satisfaction, and that would be an example of a descriptive question that would call for a descriptive study and descriptive statistical tests to analyze our data. We often in research or even in practice find things that we think somehow go together. It's almost like we notice a coincidence. And when we do that in practice in a natural setting, we can use a correlation study. A correlation study basically asks if 2 variables are related, associated, or correlated. And you can tell a correlation test type question simply because it's going to have one of those 3 words in it. So if I were to ask a question such as, is there a relationship between job satisfaction in nurses and years of experience as a floor nurse in a hospital setting? Because I use that one word, any of these 3, related, associated, correlated, or relationship, association, or correlation, then we would know that that's a correlation question that calls for a correlation study. We analyze that with a correlation test. The third group that gets even a little bit higher is our comparative group, which we're studying last week and reviewing this week. And those compare conditions of an independent variable, or in some cases, multiple independent variables. So if we ask a question, does one treatment improve the outcome for patients as compared to another treatment, that word compare makes that into a comparative type question. We often see words like increase or decrease in these questions as well. But in these questions, we will have 2 variables. We'll have an independent variable and a dependent variable, and we will not have words like relationship, association, or correlation. When we even get higher, when we understand a phenomenon more precisely or more in depth, we can get into regression analysis. Regression analysis has to do with a level of study where we're trying to predict the outcome of a dependent variable. In these questions, you'll actually see the word prediction, predictor, some version of the word predict. So if I were to ask you a question such as, does level of formal education, gender, and years of experience predict the actual level of job satisfaction in staff nurses? Because I use that word predict, you would know that that is a regression question, again calling for a regression study with a regression analysis, and we would use the regression test, and we will cover those after we complete our study of the comparative level. And finally, we get up to a level of study that I refer to as epidemiology. Epidemiology is its own discipline. It does use many of the tests in these other groups, but there are tests that we almost exclusively use for epidemiology. when we ask questions about rates, such as infection rates, when we ask questions about probability, risk or likelihood, or what are the odds. If we're looking at a question such as what are the odds of getting COVID in those who have not been vaccinated compared to those who have been vaccinated, that is a question about an elevation in risk, and we'll often see these in the research. And I group those all, I guess, rather loosely, perhaps, into this group of epidemiology tests. For me, if a statistical test doesn't fit very nice and neatly into one of the other four groups, I put it into this group. So this group has a lot of very different tests. Some of them are extremely easy to calculate. Uh, we have free apps for many of these, and I'll show you that after we get through our analysis of the regression category. So when we have a question, and I always start with a question, this will lead to one of these five groups of quantitative research statistical tests. So that's the first thing. We have to look at the question. We identify the question as being in one of those five groups. The other thing we really have to know that's going to influence the tests we choose in statistics is the level of measurement we use. And by the way, um, almost invariably, if we have a situation where we're comparing two different types of treatment or three different types of treatment, such as if our independent variable is diet, and we divide our patients into several groups, each group gets a different diet. When we have those kind of groups, it's almost always nominal data. It can be ordinal data, but it's almost exclusively nominal data. So when I'm talking about levels of measurement and what we have here, I really mean it in a sense that we have to know what our level of measurement is in our dependent variable. But regardless of that, in our independent variable, we do want to know what kind of level of measurement we have. So you will find different names used, and I learned quite a few names for different levels of measurement that I no longer use, and I exclusively use these first three. I'm of the opinion, and I've been studying this for close to 20 years, that there is actually a fourth level of measurement, and I'll go over that briefly, but you probably won't find that anywhere else. So that might just be my opinion. But basically, we have three standard levels of measurement, and we need to know these in order to be able to choose the test that we would use to analyze our data. The first is nominal. Nominal simply means name. It's a name group. There's no hierarchy or order. If we ask a patient their country of birth or their primary language and they tell us English or Spanish, Mandarin, French, or German, that's nominal level data. It's data that does not have any kind of hierarchy or order. It's named groups. Ordinal data is where we measure a variable using words, and these words have varying amounts of that variable. So if we ask nurses how satisfied they are with their job, and we give them these five choices: very dissatisfied, neutral, satisfied, very satisfied, that's ordinal data. If we ask a patient about their level of pain, we say, how would you describe your pain? Using one of these terms: no pain, minimal pain, moderate pain, severe pain. That is ordinal data. And if you look at these, this is a very important thing about ordinal data. When we give patients or, say, staff nurses terms such as very dissatisfied and dissatisfied, neutral, satisfied, and very satisfied, we really don't know what the difference is between any two ratings that are next to each other. For example, if a patient is in the hospital and they feel that they're kind of neutral, they're not really satisfied or dissatisfied with the care they're getting, and then one little minor thing happens, they press the call button and there's no response in 2 minutes, they might suddenly become very dissatisfied. It might not take much to go from neutral to dissatisfied, or to go from dissatisfied to very dissatisfied, but it might take something a little bit more, more of an experience to go from neutral to satisfied, and something significant to go from satisfied to very satisfied. And as you know, and can understand for each patient this would be different. But it's not so much the fact that that's a subjective rating that they're giving, it's that we simply don't know what the difference is between any of these two measures or things that they would responses that they would give compared to any other two. And that's the problem with ordinal data. We have what we think of as being very inconsistent units of measure between the terms we use. Our third level of data is scale data. Scale data is simply variable that's measured with a number, any number. We used to call this things like ratio, interval, discrete, continuous data, but it doesn't matter. If we have a number, we can calculate a mathematical mean. That's what's really important. And so we treat all numerical data the same. So now we just use this inclusive term called scale data. I mentioned before, I think that there is a fourth level of data, what I would call a rate. A rate is something that we see often in epidemiology, where we talk about the number of cases of an illness per population. We might see that for a particular uh, infection, that the rate is something like 2.3 patients per 10,000 in a population have this condition. It's some number that's expressed as a ratio, not to be confused with ratio data. It's a number that's expressed as a rate, such as 10 per 100, have an infection in your hospital. We have 10 patient falls per 200 patient days, something like that. And the reason why I considered this to be a different level of measure is because, as you'll see when we get to epidemiology and those tests, we do treat that data a little bit differently. And that's the only reason why I would consider mentioning this as a potential fourth level of data. So remember, nominal, ordinal, scale data. If you see a rate, you'll know that we might be using a different test for that. So what I'd like to do is go over an example of how we use this. We'll start off with a research question. That's where I always start. And because this will come up again for you, we'll talk about PICO questions. So we write questions based on what we want to know. If it's about descriptions, correlations, comparisons, predictions, or about issues of risk, likelihood, odds, etc., we write a question based on what we know. And this can be a problem too, because oftentimes we start off with a question, we write it out, and it's not really the question that we want an answer to, so we have to revise it. And this is very common. Students will start off on their final project as doctoral students, for example. They start off with a question, and invariably they have to revise it several times to really get it down to what exactly it is they want to know. The PICO question format is a format that we use in learning how to write questions. You can think of it as the training wheels on a bike. If we write out a PICO question and we go to publish a paper, typically we will refine that question and simplify it for publication. So it's more or less a format that we use in learning how to write questions. This is also a type of question we often use with evidence-based practice because we're going to compare an old way of doing things to a new way of doing things. So PICO is an acronym for the elements in this type of question, and it's called PICO because we actually write the question in this order. P is the population or problem of interest. Sometimes it's both. I is the new intervention, what we're doing. C is the comparison, the older way of doing things. And by the way, by default, the I and the C are two conditions within an independent variable. So when we have a PICO question, we don't really see the independent variable per se written in it. What we do see are the two groups that we are comparing. O then is the outcome, and it's singular. It's not outcomes. It's just one outcome. If you want to run a study and maybe have two different dependent variables or outcomes you want to study in one research study, you would simply write that as two separate questions. T is for the element of time and duration in a study. Sometimes we see these missing from a PICO because the T is thought to be optional. So that's the PICO format. So then, for example, what I'd like to do now is share an idea of what we could study we'll write a Pico question for this. We'll identify the elements of this, and then we'll go through the algorithm I devised to see which statistical tests would be best to study this question and analyze our data. So we have a research question. It's about comparing two diets and weight loss. So we could write our question as something like, and you'll see this where we put the P, which stands for the population or problem before or after that element. So we have the P in this question is in obese patients does, the I is our intervention or implementation, the implementation of the keto diet, C, as compared to having a regular diet, O, result in a greater weight loss over a 6-month period of time. So again, in this question, by default, the I and the C are two comparison groups within one independent variable. So in this case, our independent variable might be diet, and we have our two comparison groups. Some of our patients will get the keto diet, the others will get the regular diet. Then the O by default is always our dependent variable. In this case, it would be weight loss. And my thought is here we would measure weight loss in pounds, and pounds would be scale data because it would be a number. We might round off the pounds lost to the nearest tenth. So we might say that this patient lost, for example, 10.2 pounds. But it doesn't matter if we use a whole number or a negative number or zero or some number with a decimal place. It's all scale data. And that's important because with scale data, we can actually calculate a mathematical average or our mean. Again, the PICO is a training tool. We write out our PICO, and then perhaps if we were publishing such a study, we would want to simplify this a little bit simply to save space in the paper. And one of the things I often see in the literature when they do actually mention the research question is they very seldom include the element of time from the articles I've read. So if we go over this, imagine how we would set up this study. We'd start off, we'd ask patients maybe in a clinic to participate. We would get their consent. And so we would have a sample of, say, 150 obese patients. And for our particular example, we're going to say that they each weigh something in the order of 400 to 499 pounds. As they enter the study, we could actually flip a coin to determine who gets the keto diet and who gets the regular diet. So we'll say 75 of these patients or participants will get the keto diet and 75 will be getting the regular diet. So again, our independent variable here is diet. It has these two comparison conditions or treatment groups. One group will get the keto diet, the other group will get the regular diet. So there are two independent groups, but there's only one independent variable. Remember, the conditions or treatments, that actual diet they're getting is not a variable. It's not like one group gets keto diet and the other doesn't. It's one group gets the keto, one group gets the regular. Those are two conditions within our independent variable diet. In this study, we don't have a pre-test, post-test situation. That's important to note. A pre-test, post-test would be more like we were following the 150 patients. We've been following them for 6 months. They've been on a regular diet. Maybe they haven't been successful in losing weight. And now we'll start all of them on the keto diet and we'll compare weight lost in 6 months on regular diet with 6 months of the keto diet, but all participants would be treated the same. That would be a pre-test, post-test design. We do not have that in this situation. All we basically have are two groups we're going to compare, and at the end of the study, we're going to have one score for each of them, and that'll be their pounds lost in scale data. We also want to note at the beginning how we're going to record this. So somebody who has a 10-pound weight gain might be a 10. Someone has no weight gain or weight loss would be a 0. And maybe somebody who loses 10 pounds would be a minus 10. It's important to know this so that when we're looking at our numbers, we know what they mean. In terms of positive and negative, that can be a little confusing. So we want to be upfront about that and think about that carefully, how we're going to be recording our data. Anyway, this is scale data. And remember again, with the scale data, we can calculate the mathematical average or the mean. So my question then is, based on this study, this brief overview of such a study, which statistical test would we use? At the end of the study, we have um, 75 in one group. We have each of their weight loss in pounds, and we have 75 in a separate group. We have each of their weight loss in pounds. So let's go through the algorithm and see how this would play out in determining which test we use. I always start at the top. I always start with the question. So the first thing is this a descriptive statistics question? Those questions have only one variable. They're how much type questions, and we already know we have two variables, right? We have diet and weight loss, so we can rule out our descriptive statistic group. That won't work for this question. So we go down to the second group. The second group is the correlation group. These are questions about correlations, relationships, and associations. And if we look back at our question, just to be clear, if I can find it. If we look at our PICO question, we do not see these words here. We do not see relationship. We do not see association. We do not see correlation. So this question, in obese patients, does the implementation of the keto diet as compared to having a regular diet result in greater weight loss over a 6-month time period? Because it does not have any of those three words in it, it cannot be a correlation group type question. So we go to the next group. The next group, the comparative group, by default, any PICO question does fit in with this group, but basically here we're asking questions about comparisons or differences, which may be stated as an increase, decrease, improve, change. And if we look back again at our PICO question, we do have one very significant word in the question, the word compared. So going forward, of course, if you see a PICO question, you can automatically rule out all of the other statistical groups. It's not a descriptive, it's not a correlation test, it's not a regression test, it's not an epidemiology test most of the time. That one word compared is going to push this question into the comparison group. So we could stop and jump off here. In the algorithm, you would go to slide 14. I have a modified algorithm here for this example. So I'll just go through that really quickly. Again, with the descriptive statistics, I have the types of tests that come out here, such as the mean, median, mode, ranges, percentages. It's not a correlation test. Those tests are tests like the Pearson's, Spearman's Rho, Kendall's Tau, the point by serial, and the phi are the ones I see most often. So it's not in one of those. And so in the algorithm, if we jumped off here where it says go to slide 14, you would wind up on this slide. I'm sorry, I have a cold this morning. So you'd wind up on this side, and this slide is where we enter the decision to try to figure out which of our comparative tests we would use to analyze our data for our diet and weight loss study. So the first question I pose is, how many conditions or groups does the independent variable have? Well, if you recall, our independent variable is diet, and we have two groups. We have keto and regular. So down on the left, I have 2 or less. We go to the t-test track. 3 or more, we go to the NOVA. So because we only have 2, we just ruled out all of the NOVAs and all of their non-parametric equivalents, which is a large group of tests. And I can tell you right now, just knowing that we have a question about comparisons, and knowing that it's not a pre-test, post-test, and knowing that we have 2 groups in our independent variable, we've just eliminated all the possible statistical tests out there down to only maybe 6 or 7 possible tests that we could use to analyze our data. So we're on what I call the t-test track. The next question, is it a pre-test, post-test design? We already said no. We're basically studying 2 independent groups. This brings us to only a few tests left. The single sample t-test, the independent samples t-test, the Mann-Whitney U, or the chi-square. And we referred on to slide 17. So it's not a paired t-test. Those tests come here. This is the slide we would go to. So the last thing we need to answer to determine which test we use is what kind of data do we have in the dependent variable. And you can see there's only really three choices at this point. If it's scale data, which it is, it's pounds, we would use the independent samples t-test. So that is the correct test given our study. If it had been ordinal, we'd use the Mann-Whitney U. If it was nominal, we would use chi-square. So that is a quick review of our comparative group. Given our PICO question, we would go out and have our study of 150 obese patients. We would put half of them in a group with a keto diet, half in a regular diet. After 6 months, we'd weigh them, we'd record their pounds lost. So for each group, we'd have one number per patient or participant. We could get a mean of each group because it is scale data, right? It is pounds are measured in weight loss. It's a number, scale data. So for each group, for the keto diet, for the regular diet, we could obtain a mean of pounds weight loss, and our independent samples t-test would compare those two to see if there's a significant difference. This concludes our review of the comparative group, and in our next presentation, we'll go through the regression group.